Let's take a look at talking about the magnitude of z. We're going to stay in our complex plane, and I have my grid here. I've drawn out my real axis and my imaginary axis, and we're going to take a look at plotting a number. We'll call it z, right? It's in the form x plus yi. So if I graphed it here in my first quadrant, right, this would be the equivalent of my x value, my y value. My z point is plotted somewhere up here. And if we're taking a look at the magnitude of z, z would be the equivalent of our hypotenuse. Right? So this would be a right triangle. We can use our Pythagorean theorem. So x squared plus y squared. And we're going to go ahead and take the square root of that. That's going to give us the equivalent to the magnitude of z. Let's talk about some notation if we want to write z, which is x plus yi, in polar form. Keep in mind, polar form means we're going to have r and theta in place of those x and y values. So recall from an earlier section, x was equal to r cosine theta, and y is equal to r sine theta. And we're going to use this to rewrite z. So I'm going to go ahead and use z equals x plus yi, and all I did was substitute for my x and y values. So in place of x, I put my r cosine theta, and in place of y, I put my r sine theta. Don't lose the I that's all the way there at the end. That's one way you could write this. Let's talk about one more notation piece, because these both have an r in common. So the other way you could write it is to go ahead and factor the r out. On this last step, I went ahead and factored the r out. Inside my parentheses, there's my cosine theta plus I sine theta. You can put the I all the way out in front of this sine theta value, or you can leave it at the end, whichever is your preference.